In this lesson, we will learn about simple and compound interest. Let's begin with simple interest. By definition, this is money that is earned or owed on the original amount that was invested or borrowed. The original amount is always referred to as the principal. The simple interest formula is shown below. I equals P times R times T, where I is the interest, P refers to the principal amount, R is our annual interest rate, and T would be the amount of time that has elapsed. One important thing, in order to use this formula correctly, both R and T have to have the same units. Oftentimes R is expressed as an annual interest rate, so T then must be expressed in years. You will often see annual interest rates expressed as per annum. This is just a phrase that means once per year. Simple interest is just used to determine interest that has accumulated. Oftentimes a question will ask you for the future or final amount. To do this, you just take the interest that has accrued and add it to the principal. The formula would be A equals P plus I, and in this context we often use A to represent the future amount. Let's try out an example. Alex is borrowing $3,000 as a student loan. This would be the principal amount. The bank charges him an interest of 7.8% per year. That would be your annual interest rate. And we want to know the ending balance after 5 years. So that will be the time that has elapsed. We'll get started by calculating the simple interest. So I equals P times R times T. The principal amount is $3,000. The annual interest rate is 7.8%. We need to convert this to a decimal though, so divide by 100 to get 0.078. And T is the time in years, that's 5 years. Multiply these three numbers on your calculator and you should get 1,170. Please note this is just the interest that has accumulated over the 5 years. The question is asking for the ending balance, so we need to calculate the future amount. To do this, we use the formula for the future amount, P plus I. We had a principal of $3,000. Add the simple interest that has accumulated, and that'll be a final value of 4,170. Remember, in math, it's always good practice to write a concluding statement, so let's do that. Okay, moving on. In this example, we're investing $2,500 in a bank that offers interest of 4.5% per year, and we'd like to determine the interest after 39 weeks. So again, the 2,500 is the principal amount, the 4.5% per year is the annual interest rate, and 39 weeks represents the time that has elapsed, P, R, and T. To calculate the interest, we use our simple interest formula. And substitute $2,500 for the principal, the annual interest rate of 4.5%. Once again, please don't forget, this always has to be expressed as a decimal. Just divide your percent by 100 to get that. And be careful with the T over here. It was given as 39 weeks, but the interest rate is per year. So we need to convert those weeks into years. To do this, you can just take the 39 weeks and divide by the number of weeks in a year, which is 52, and leaving it as a fraction like that, you'll ensure that your time is in proper units of years. All right, working this out on your calculator, you should get approximately $84.38. Please remember, with money, always round to 2 decimal places. And that's that, so let's write a concluding statement. Okay, moving on. In this example, Bob is investing $4,850 in an account that pays simple interest at a rate of 7.6% per year. In this case, Bob would like the money to increase to a final value of $8,000. This question is different because it's asking now for how much time we need the money to invest. So let's look at what we were given. The $4,850 is our principal amount. We have our annual interest rate of 7.6% per year. And in this case, the final value of $8,000 represents A. In terms of how long he needs to wait, this is time. So to find time, we have to use the simple interest formula. I'll just write it down. I equals P times R times T. But we don't know I, the interest earned. But luckily, we can use A and P to find that. So just rearranging the formula for A, recall A equals P plus I. Rearranging, we get that I equals A subtract P. Let's do that to calculate the interest that has been accumulated. So that's $8,000. Take away the principal of $4,850. And that means we've earned simple interest of $3,150. Now that we have that, we can go back to the simple interest formula and rearrange for time. So I'll do that up here. Time is equivalent to the simple interest divided by P times R. Let's plug in what we have. Simple interest is $3,150. The principal, be careful here, that's the original amount, so that would be $4,850. And the annual interest rate as a decimal is 0.076. Okay, work that out on your calculator, and you should get approximately 8.54. What are the units? Well, remember, R and T have to be the same units. So if the interest rate was expressed per year, then the units of time are years. That means Bob will have to wait almost 8.5 years in order for his initial investment to reach $8,000. Let's write a therefore statement. All right, and that's going to wrap up simple interest. The second part of this lesson is related to compound interest. Compound interest refers to money that has been earned or owed on the original amount that is invested or borrowed as well as any interest that has previously accumulated. So to put it simply, compound interest includes the original amount plus interest on the interest. It compounds, almost like a snowball rolling down a hill, how it keeps picking up more and more snow. Compound interest is beneficial in the sense that the money compounds or builds up over time. Let's take a look at how it works. Imagine you invest $1,000 in a bank that offers you 5% compound interest. We're told that the interest is compounded once per year, so that would be 5% per year. We're looking at the balance after 5 years. So here's how compound interest works. You begin in year 1 with a starting balance of $1,000 because that's what was invested. The balance that interest is calculated on is the $1,000 that was deposited. Now to calculate the interest, notice that we're using the simple interest formula again over here. So let's do that to see how much interest is earned after 1 year of leaving the money invested. So the interest would be the principal of 1,000 multiplied by the annual interest rate of 5% multiplied by 1 year, and working that out on your calculator, you should get 50. That means in 1 year, your $1,000 has accumulated $50 of interest. At the end of the year, you add the $50 to your original, and you now have a balance of $1,050. The ending balance at the end of year 1 becomes the starting balance at the beginning of year 2. Write that in over here. Now with compound interest, you're calculating interest on the $1,050, not just the $1,000, which is what simple interest did. All right, so now to calculate the interest, we use the new principal of $1,050. Once again, multiply by the annual interest rate of 5%, and we'll see how much is left after 1 more year. Working this out on your calculator, you should get an interest of $52.50. Notice you earned more interest because the starting balance was larger. Add the $52.50 to the beginning balance to give you an ending balance of $1,102.50. The ending balance at the end of year 2 becomes the starting balance at the beginning of year 3. That balance is what we're calculating interest on, so write it in again. And this is the essence of how compound interest works. This would be a great time to pause the video, try to calculate the rest of the table, round all of your values to 2 decimal places, and when you're ready, click play to resume. Okay, here we go. Compare your results with that in the table, and you'll see that after 5 years of compounding your money, you should end up with a final balance of $1,276.29. The thing to take away with compound interest is after each year, the balance that you're calculating interest on has increased. So just to summarize, compound interest earns interest on the original amount plus any interest that has accumulated. Because the interest was compounded annually, that means once per year, we were taking the balance at the end of the year, and that allowed it to become the new balance at the beginning of the next year. This is what is known as the compounding frequency. We'll get into this a little later in the lesson. So as you can imagine with compound interest, it does become a bit tedious if you had to go row by row like we did in the example above. What allows you to do this in one shot is the compound interest formula. This is shown below. In this formula, A refers to the future amount, P once again is the principal amount, lowercase I refers to the interest per compounding period. I'll get into that shortly. And lowercase n refers to the total number of compounding periods. To find your interest per compounding period, what you do is take your annual interest rate, this is still referred to by R, and you divide that by the number of compounding periods. This is shown below. So capital N over here refers to how many times interest is calculated per year. To find lowercase n, we take the number of years and multiply it by the number of times interest is calculated per year. So that's what I'm using as lowercase n, the number of compounding periods. Capital N would be the number of times interest is calculated per year, and lowercase y would represent the number of years. There are some key phrases to keep in mind when working with compound interest. When interest is compounded annually, that would be once per year. Semi-annually is twice per year. Quarterly refers to 4 times per year. That would be every 3 months. Monthly is once per month or 12 times per year. Bi-weekly, that would be 26 times per year or every 2 weeks. Weekly would be once a week or 52 times a year. And lastly, you can even imagine compounding your money daily. That would be every day or roughly 365 times a year, not including leap years for simplicity. With that being said, let's do a compound interest example. Melissa's grandparents invest $5,000 at a rate of 4.8% per annum, and the money is compounded quarterly. The money was invested when she was born, and we'd like to determine how much the investment will be worth on her 21st birthday. So this is compound interest. Let's write out the formula. Whenever I'm working out compound interest, I like to show some side work to get the interest per compounding period as well as the number of compounding periods. So the interest per compounding period, you take your annual interest rate of 4.8% and divide by the number of times interest is compounded per year. Since it's compounded quarterly, that's 4 times per year, and that'll give you an interest rate of 0.012. And in this case, this represents the interest per quarter. To find the number of compounding periods, little n, we take the number of years, in this case 21, because on her 21st birthday that would have been 21 years, and we multiply by the number of times interest is compounded per year. Because it's quarterly, that's 4 times per year, for a total of 84. This represents the number of compounding periods. Okay, you can substitute those into the compound interest formula. So the principal is $5,000 multiplied by 1 plus I to the exponent of n. Please don't forget the BEDMAS rules when you're working this out on your calculator. You're going to have to work inside of the brackets first, so add those two numbers. That'll give you 1.012. to the exponent of 84. Once again, please don't forget BEDMAS, so you're going to have to take the base of 1.012, raise it to the exponent 84. Your calculator will give you a number. For me, I think it's best just to do this in one shot. Multiply that number right away by 5,000, and that should give you a final value of approximately $13,618.62. That means after 21 years, the initial investment of $5,000 has increased to $13,618.62. The investment has more than doubled. Okay, moving on. In this example, imagine you have a credit card that charges interest at 24% per year, and imagine it's compounded daily. In our example, Nicole forgot to pay her credit card bill for a period of 73 days, that's over 2 months. And if she had a balance of $1,267.80, how much interest would she be charged? Well, to get started, let's figure out I and N. So the interest per compounding period would again be the annual interest rate of 24% divided by 365 because the interest is compounded daily. All right, this should give you approximately 0.00066. Now n, the number of compounding periods, because it's compounded daily and she didn't pay her credit card bill for 73 days, it's just simply 73, the number of days. Okay, that being said, the compound interest formula is A equals P multiplied by 1 plus I to the exponent n. We have a balance of 1267.80, that's the principal, multiplied by 1 plus I to the exponent of 73. Once again, simplify inside of the brackets first, so BEDMAS still applies. And just to reiterate, you have to take your base of 1.00066, raise that to the exponent 73, and then whatever that number is, multiply by the principal of 1267.80. After doing so, you should get a final amount of $1,330.36. Please note, this is just the final amount, including the principal. The question was asking for the interest. So we're going to have to use that formula we saw from earlier. The final amount is always equal to the principal plus the interest. You can use this formula for compound interest as well. Rearranging for I, you take the final amount and subtract the principal, so let's do that. You should get a final value of about $62.56. Okay, moving on to our last example. We're told that Kevin would like to go to Japan in 5 years, and he estimates he'll need $3,000 to do so. In this question, we want to work backwards. How much money should he invest today if his investment will earn 3.6% per year compounded quarterly? So in this case, we want to work backwards to find out the principal value that should be invested today. Let's begin by writing out our compound interest formula. Now, we have to rearrange this for P, the principal. To do so, just divide both sides of the equation by the expression in brackets. And that'll allow you now to solve for P. As before, let's do some side work. The interest is the annual interest of 3.6% divided by 4 because it's compounded quarterly. This will give you 0.009. And the number of compounding periods would be 5 years multiplied by 4 times per year. That gives you 20. And with that being said, we're all set. So P equals the final amount of $3,000 divided by 1 plus 0.009 to the exponent of 20. So P equals $3,000. Inside of the brackets, you're going to add the two numbers to get 1.009. And once again, that's to the exponent 20. So work this out on your calculator, and you should get a principal value of $2,507.83. Does your answer make sense? It should, because the principal value is less than the final amount, which is exactly what you would expect. So therefore, Kevin should invest $2,507.83 today. And that concludes this lesson on simple and compound interest.